everyone to my lecture today. Today, um, December 11, 2020. I'm actually going to be walking you through another fascinating topic in statistics. And of course, our focus today is actually going to be two samples hypothesis testing. Now, you remember before now, I introduced you to hypothesis testing, uh, hypothesis testing of population parameter. We've considered hypothesis testing in one population, but the focus today is actually going to be on two populations, okay? So that is actually going to be the focus today. Okay, so the outline, we're going to talk about inferences about two proportions. And the inferences that I'm talking about is more or less the hypothesis testing about two proportions. Okay, we're also going to talk about about two means, particularly independence for independent samples. Okay, so um, that is going to be our focus today. Okay, so uh, let's have a review. We're actually going to present a method, so statistical method that can be used to test claims, okay, made about population parameters. Of course, um, an example of such, the claim there could be a claims about proportion, there could be a claims about the difference of means or difference of proportions, and so on like that. Okay, so of course the objective is just to extend the methods of estimating values, okay, of population parameters and the method of testing hypothesis, of course, to situation where we have two sets of sample data, okay, not just one. The one we've done before, we actually tested the validity of a claim in one population, okay. Okay, so an example of such is this, okay, test the claim that when college student are well, okay, at the beginning and at the end of their freshman year, the differences show a mean weight gain of 15 pounds. Okay, so this is an example of an hypothesis testing uh, for difference of parameters in two population. Okay, if you take a look at what I'm showing now, so this is require us testing hypothesis about difference of means. Okay, the means of what? The means of weight, okay, the weight at the beginning and the weight probably uh, at the middle of the semester. Now take a look at this, another example right here, where we may want to test the claim that the proportion of children who contract polio is less for children given the Salk vaccine than for children given a placebo. Okay, in fact, what is happening now in the world, more than two companies have claimed to develop vaccine for COVID. Okay, now for instance, if we use a vaccine from Pfizer, okay, of course the Pfizer claim 95% efficacy rate. If we use vaccine from Pfizer and we compare that with placebo, okay, the placebo, okay, is more or less like um, we got some set of individuals, and we divide them into two groups, and we give Pfizer vaccine to some people, in the first group, and we give placebo to the second group. The placebo to the second group is more or less means we're giving nothing out because the placebo does not have any effect. So that is more or less comparing the Pfizer vaccine with nothing. Okay, comparing Pfizer vaccine with nothing. Okay, so that's an example of test of difference of proportion, because you actually want to see um, even before the vaccine, you know that some people have they've maintained ability not to contact COVID. Okay, so with the Vasa vaccine and without vaccine at all, okay, can we have a difference between the proportions of those who are able to prevent COVID? We can have a test like that. Okay, can actually have a test like that. Now, another one here, test the claim that the subject treated with Lipitor have a mean cholesterol level that is lower than the mean cholesterol level for subject given a placebo. Okay, maybe probably you are looking for a way to reduce the cholesterol level of people, and you decided to give them a Lipitor. Okay, probably a Lipitor, maybe it's an experimental uh, treatment, and you actually want to compare that with the effect of placebo. You want to see whether the Lipitor will reduce the cholesterol level of people, lower than the just not applying anything. Okay, so these are examples of difference of means, hypothesis testing involving difference of means and difference of proportion. Okay, so I want to visit them one by one. I want to focus on inferences about proportions. Okay, now and of course we actually want to develop a method for testing a claim made about two population proportions. Okay, do you know there's a way you can compare the efficacy rate of two vaccines? Okay, now right now the Pfizer company, the AstraZeneca in the United Kingdom, and the Moderna here in the United States, the three companies have claimed to have a success story in their clinical trial of the vaccines. Okay, and of course, do you know that we can have a way to compare the efficacy rate of two vaccines? Vaccines from two different companies. We actually want to see whether they have the same efficacy rate or not. Of course, that hypothesis is an hypothesis testing of difference of proportions. Okay, difference of proportion. Okay, so if you want to do that, let us assume that we have a population one. If population one, okay, because in the hypothesis testing for two or for the difference of proportions in two population, of course, you're actually going to have population one and population two. Now, take a look at population one right now. What are we looking for in population one? Okay, in population one, we believe we're looking for population proportion. Okay, the population proportion is a true value, okay, of the not of the the true value of the proportion we're looking for. Okay, but you know what, we are only going to get the population proportion if we have been able to examine all elements in the population, and that is not what we do. We don't do that in research. In research, what we always want to do, we're actually going to take a sample. And you know what, when Moderna, Pfizer, before they could claim an efficacy rate of 95%, they've conducted a clinical trial where they made use of the sample of subjects. They did not actually use everyone in a population. Okay, so which means we are not going to get a population proportion, but we can actually estimate that. Okay, in order to estimate the population proportion, what we're actually going to do, we're going to take a sample size. Okay, N1 is the size of the sample. Okay, so taking a sample size, just like what a Pfizer did when they were trying to understand the efficacy rate of their vaccine, they actually took a sample size of people. Okay, and of course they fascinated these people, and what are they looking for? They're looking for S1, which is the number of successes in the sample. Of course, the number of successes in the sample is actually going to be out of the sample they use, how many out of the number of people they vaccinated with their vaccine. Okay, how many of these people were able to prevent the occurrence of COVID? Can you guys confirm if you guys are still hearing me? Okay, now what I'm trying to talk about right now, the X1 is the number of successes in the sample. And of course, the company will want a situation whereby they're going to record a good number of successes. Okay, now, so if you now want to estimate the sample proportion right now, then it's actually going to be the ratio of the number of successes to the sample size collected. Okay, so which means the sample proportion is actually going to be the ratio of the number of people that were able to prevent the occurrence of COVID after being vaccinated. Okay, so of course, Q1 here is actually going to be, you know, the probability of failure. Okay, the probability of failure this time around is actually going to be, out of those people that were vaccinated, how many of them were not able to prevent the occurrence of COVID? Okay, and that is going to be seen as a probability of failure, which is 1 minus P1. Take a look at that. Okay, so what you actually do to population 1, you're actually going to, do the same to population 2. Okay, so let me tell you this. What I'm trying to tell you right now, the two population, one may actually be some set of people, you know, where you actually take a sample size from a population that you fascinate. And the second population may be probably the population that will not be fascinated. Okay, you take a sample size and you don't fascinate them, and you now actually want to compare whether there's a difference between getting a COVID vaccine or not getting a COVID vaccine. Of course, you're actually going to conduct what I call hypothesis testing of difference of proportions. Okay, and you know what? Not only that, we're going to compare experimental treatment with placebo. Do you know that you can also compare the efficacy of two vaccines? Okay, you can also, a lot of people have been debating right now whether whether people will have option, or we have a choice between vaccines. Okay, some people may be okay. Maybe what I want is Pfizer vaccine or Moderna vaccine or AstraZeneca vaccine. But you know what? We can also have a way to test if there is a significant difference between the number of, between the efficacy rate of of any two given vaccines. Okay, we can also achieve that using the test of difference of proportions. Okay, so take a look at that. And of course, there's something that we call pool sample proportion. In this pool sample proportion, that is symbolically represented by P bar. And of course, what are we going to do? We're actually going to add the number of successes in the two sample divided by the totality of the samples taken randomly from two populations. Okay, now and of course, when I have a P bar, I'm actually going to have a Q bar, because a Q bar equal to 1 minus P bar. Okay, now if you want to conduct hypothesis testing, okay, for difference of proportion, of course, we have requirements. Okay, we got requirements. Okay, the requirement is just that number one, we have proportions from two independent simple random samples, so which means there shouldn't be any favoritism or biasedness in the selection of sample from the two populations. So we got to use the principle of chance, the principle of randomization. The way we select sample from the two populations have to be random. Okay. Now, number two, for each of two samples, let me just say this. The way we select samples have to be two random. And in a situation where I want to test the efficacy rate, I want to compare the efficacy rate of two vaccines, okay, then it means I'm actually going to randomly select, I'm actually going to randomly assign subjects to the vaccines, okay? Any of the subjects have equal chance or probability of being assigned to any of the vaccines, okay? So we shouldn't allow, we shouldn't be biased in our randomized, in the assignment of subject to the vaccine. That's exactly what we're talking about right here. Okay, so, and of course, for each of the two samples, the number of successes should be at least 5. And the numbers of failures should be at least 5. What do we mean by that? Okay, NP has to be greater or equal to 5, and NQ has to be greater or equal to 5, when you consider the two samples from the population. Okay, now, if we want to conduct an hypothesis testing on proportions, okay, now take a look at this. You remember the other time I told you there are three values, there are three symbols the non-hypothesis can have. You can have a less than, they can have a less or equal to, it can have greater or equal to. Okay, and there are three value, there are three symbols the alternative hypothesis can have. It's either you have a not equal to, the less than, or the greater than sign. Okay, but you know what, in the hypothesis testing involving proportions, we may decide to use equality all the time for the non-hypothesis. There's no problem about that. Okay, whether equality sign or less or equal to or greater or equal to, we can still take that as equality. Okay, and under the non-hypothesis. Okay, so, and of course, it means if I'm testing hypothesis, I want to test this hypothesis against this guy here, or I want to test this, it's either against this guy here, or this guy against this guy, or that guy against that guy. Take a look at that. The alternative hypothesis can, we actually have three of those nature. Okay, and if I want to do that, I need a test statistic. Okay, so what is the test statistics to do that? The test statistic is actually this guy here. Okay, take a look at that. What is pickup one? What is pickup two? The pickup one, the pickup two are the sample proportions. Okay, these are sample proportions, and these are population proportion. But you know what? Under the non-hypothesis, if P1 equal to P2, then when we're trying to talk about the P1 minus P2 equal to 0, okay, you may not necessarily require the difference of population proportion, because under the non-hypothesis, there's no significant difference, which is more or less 0. So, of course, this is what we have right now. And of course, you know how to get a P bar, and you know how to get a Q bar, okay, that I showed you before. Okay, if that is actually going to be taken, um, okay, so like I said, P1 minus P2 equal to 0. The P1 and the P2 are the population proportion, okay? The population proportion is different from sample proportion. This population proportion is, we are testing the value of population proportion under the hypothesis, okay? So I think you get that now. Okay, so this is going to be, if you want to get a pickup one, pickup two, like I mentioned the other time, of course, the pickup one is sample proportion, which is actually the ratio of the number of successes in the sample to the totality of the sample that we choose, okay, from the two population. Okay, so, and this is the formula if you want to figure out the P bar. Okay, the P bar here is automatically the totality of the successes in the two sample divided by the totality of the sample. Take a look at that. Okay, and the moment you get that, you can actually figure out your Q bar. Can you guys still confirm if you guys are still hearing me clearly? Okay, thanks for confirming that. Now, let us look at a question right now. You know, I gave you this question before when we're constructing hypothesis, confidence interval for difference of proportion. But right now, what we actually want to do, we want to test an hypothesis. Okay, take a look at this. The table below lists results from a simple random sample of front seat occupant involving car crashes. Use a 0.05 significance level to test the claim that the fatality rate of occupants is lower for those in cars equipped with airbags. Okay, now let me tell you this. Do you know you can conduct a research where you can actually, you know, investigate, because in the United States right now, you know, there have been a kind of debate, okay, among people whether people should wear face masks or not. Okay, do you know that you can actually investigate whether wearing face masks is actually to prevent COVID, whether it's going to be helpful or not? What you're actually going to do, if you know the if you have access to the data of those who have catch COVID, okay, then we can ask them question about whether they have been wearing mask or not. Okay, and we're actually going to compare. Okay, so do you know you can also do that here too? Now, but in this question, want to uh, we actually want to compare fatality. Okay, you know, the fatality rate of occupants. You know, for cars, you know, we got a car with airbag. Okay, and we get you know, where no airbag is available, and of course out of the total number of occupants we have in the car with airbags. 11,541 is the total number of occupants we have in the car with airbag. Of course, 41 of them, okay, actually die when was a crashes. And out of 9,853 without airbag, of course, 52 of them actually die. So what we want to do now, we want to compare fatality in, in two situations. Situation where airbag is available in a car and when it is not available in a car. Okay, now if you want to do that, of course, we actually have a steps. Okay, and of course, in the step, you need to first investigate whether the assumption on the line that is met, where you're actually going to do N1 P1 is it greater or equal to 5, N N2 P2 is it greater or equal to 5, N1 Q1 is it greater or equal to 5, N2 N2 Q2 is it also greater or equal to 5. Of course, you're actually going to investigate that. Okay, and what is going to be your N1? Of course, your N1 is this guy here. Okay, this guy is your N1. Oh, sorry, give me 1 second. That is not your N1. This guy here is your N1. This guy here is your N2. And this guy here is your X1. This guy here is your X2. Look at that. Okay, so you know your N1 now, you know your N2 now, you know your X1, you know your X2. Take a look at that. Okay, and of course, with this information, you can actually obtain your pickup one. Okay, your pickup one is actually going to be X1 over N1, and of course, your pickup two is actually going to be S2 over N2. Look at that. You got a pickup one, you got a pickup two now, because that's going to be the ratio of that. Take a look at that to that. Okay, so now when you get that one right now, the next thing you're actually going to do, you've already investigated, and of course, we know that when you multiply N1 by P1 has to be greater than 5. When you multiply N2 by P2 has to be greater than 5. Of course, you have done that. Now, after investigating whether the assumptions are met or not, the next thing you're actually going to do is to, formulate your hypothesis. Now, if I want to formulate my hypothesis right now, I'm actually going to go to the question. Take a look at the question right now. Let's look at the claim. What is the claim? It said, use a 0.05 significance level to test that the fatality rate of occupant is lower. Take a look at this guy here, lower. What do you mean by lower? That's a less down. Okay, that's a less down. And where can you have a less than? You're actually going to have a less than at the alternative hypothesis. Okay, the claim here, the question now is talking about less than. There could be some question where they could be talking about greater than, they could be talking about not equal to, but right now, this particular question is talking about less than, and that is where am I going to have the less than? I'm actually going to have that as the alternative. Okay, and of course, what is the opposite of that? The opposite of this guy here is actually going to be greater or equal to. Okay, it's going to be greater or equal to, and of course, we can simply write equality under the non-hypothesis. Okay, you can equally write equality under the non. So what we are trying to talk about now is that under the non-hypothesis, the fatality rate is the same, but under the alternative, okay, one has a fatality rate lower than the other. That's what we're trying to talk about. Okay, one has a fatality rate lower than the other. Okay, now then the next thing you're going to do, we need to specify the level of significance. Of course, I used to tell you, you're actually going to have you need to disclose the level of significance, which is a level of statistical error, and of course, symbolically represented by alpha, which is 5%, which is 0.05. Okay, then the next thing you're going to do, you're going to get your p bar. Okay, your p bar is just going to be the addition of the total of the ratio of the total of the characteristics of interest to the total number of samples. Of course, you can see that, and this is my p bar right now. And then after getting my p bar, I can actually get my q bar. Okay, because my q bar is going to be 1 minus p bar. Okay, so that is actually what you're going to have. Okay. Now, when you are done with that, the only thing you need to do, you're just going to go to the Z formula right now, where you're going to plug in the values. And of course, don't forget I said this is the difference of population proportion, which is equal to 0 under the null hypothesis. The value equal to 0, okay? But here you're going to plug in the pickup 1, the pickup 2 that we have obtained, okay? And the P bar and the Q bar, and that is exactly what we have right here. And right now, what do we have? We got this result. The Z equal to minus 1.91. That's a Z score, okay? That's a Z-score of the test. Okay. Now, after having a Z-score right now, it's actually going to be easy. What we're going to do next. Okay, what you're going to do next now is you need to find a p-value associated with that, which is going to be the probability of Z-score. And if you want to know whether it's going to be greater than or less than or not equal to, you're actually going to check the nature of the alternative. Okay, the nature of the alternative right now is less than. Okay, so because the nature of the alternative is less than, if you want to find your p-value right now, you're actually going to say p of Z less than minus 1.91. Okay, and of course, if you want to get that in R, it's actually going to be P norm. Okay, P norm of minus 1.91, and automatically you're actually going to get your result. Okay, so when you get your P value right now, the next thing you're actually going to do, look at that. That is the P value you're actually going to get. Now, take a look at this P value right now. It's 0.0281. So you got to compare the p-value now with the level of significance given. And of course, a 0.0281 is less than a 0.05 level of significance given in this test. Therefore, we are actually going to reject the non-hypothesis. Okay, rejecting the non-hypothesis right now, then it has confirmed the claim. Okay, it confirmed the claim that fatality rate in cars with a lower, with a airbag, the fatality rate with cars with a airbag is actually going to be smaller than, it's going to be lower than the fatality rate with the cars with no airbag. Take a look at that. Okay, you can see that right now. So that is how, that is the decision you're actually going to take regarding the test. And you know what? When we did this using a confidence interval, we took the same decision the other time, because using a confidence interval, for there to not to be a different, or for there not to be a different, we expect to have a 0 in the in the range of the interval. And you realize the other time the result that we have was the lower bound and the upper bound was positive and positive. So which means there was no 0 in the interval, and there is no 0 in the interval using a confidence interval, then it means you're actually going to reject the non-hypothesis. Okay, so the result of our research right now is actually coincided, actually agree with using the confidence interval. So what is going to be the conclusion right now? Take a look at that. What we are trying to say to the world right now, they should have airbag in their cars, because having a airbag is actually going to save life. And that's exactly what I have right here. Okay, that's exactly what I have here. As a result, it appears that airbags are effective in saving lives. Okay, take a look at that. You can do the same if you want to, you can conduct an independent study where you can look at the effect of face masks, okay, the face masks in preventing disease, okay. There's a mandate. That is why I normally want, if we put politics aside, okay, if we put politics aside, I want us to always, although we find ourselves in a world where we cannot totally put politics aside, because we live in a political environment. But you know what? Despite that, we also need to pay more attention to science. Okay, we need to pay more attention to science. We need, if those that are debating whether fixed marks is actually going to help in preventing COVID, they should conduct a research and see those who have already catch the COVID. Okay, now let us know how many of them actually use fixed marks. How many of them did not use fixed marks? From there you'll be able to know the probability. You'll be able to know whether using a fixed mass is actually going to help or not. Okay, so now that's all about hypothesis testing on the proportions. The next thing I want to talk about now is hypothesis testing of difference of means. But before I start the hypothesis testing of difference of means, can we actually, is there anybody who want to ask question or who need clarification? Can you guys confirm if you guys are still hearing me clearly? Is there anyone who need clarification right now? If you guys are good, if you guys really understand what I've explained today, I need you to comment yes or you say yes. Okay, good job. So it means you guys really understand what I explained right now. Okay, now the next objective of today is actually, you know, to want to have hypothesis testing about the difference of means. Okay, the what we just concluded right now is having hypothesis testing, you know, about the difference of proportions. Okay, but it is not all the time. In some real life situation where we maybe want to compare the means, excuse me, want to compare the average. Okay, now so we want to talk about the one that has to do with independent samples right now, and of course we actually want to compare the means in each of them. Now you remember the other time when I was talking about confidence interval of difference of means, we consider different scenarios. Okay, scenario where the population standard deviation is known, situation where the population standard deviation is unknown and stuff like that. We're also going to consider that right here. Okay, now the part one right now is, I'm talking about independent samples, but you know what, from two populations, but you know what, the sigma one and the sigma two are unknown, which means I don't know the population standard deviation of the two population. They are unknown, but you know what, they are not assumed to be equal. Okay, they are unknown and they are not assumed to be equal. Okay, so how can we actually test for difference of means in such in this kind of population where we don't have access to the population standard deviation and of the two population? Okay, now if we want to do that, what we actually going to do, take a look at this. Just like we want to have some notations right now for the first population. For the first population, we're looking for population mean, but we can only get population mean if we study everybody in the target population. There's no way we can do that. Okay, there's no way we can do that because we don't study every item in the population. No, we don't have resources, for that. Because of that, we're actually going to take a sample. Okay, and from the sample, we're actually going to obtain the sample mean. Okay, then we're going to get a sample standard deviation. A situation where the population standard deviation is not given, we're actually going to obtain sample standard deviation. Okay, so take a look at that. We're going to do the same thing to the second population. Take a look at that. And what are the requirements that we're talking about? The requirement is that, okay, the sigma one, the two population standard deviation symbolically represented as sigma 1 and sigma 2 are unknown. Okay, and no assumption is made about the equality of that. Okay, so those are the requirements, and of course the two samples are independent. Okay, the two samples are independent, and both samples are simple random samples. Okay, simple random sample because we choose the sample from the populations of interest using principle of randomization. Okay, using principle of randomization. And the fourth condition is that the sample size has to be sufficiently large. Has to be sufficiently large. The N1, the N2 has to be greater than theory. Okay, and they have to come from normal population, or both come from normal population. Okay, so if you are not choosing from normal population, this has to be satisfied. The only condition under which that are not satisfied is when the samples are coming from normal population. Okay, so that is the only condition on that it is not satisfied. Okay, so to take a look at that, Okay, so if that happens, what is actually going to be the test statistic? Of course, the test statistic is going to be T. Look at that. It's actually going to be T. Now, I'm going to repeat that right now. Situation where the population standard deviation are not given. Okay, the population standard deviation are not given. Okay, so if the population standard deviation are not given, you're actually going to make use of the formula I'm showing you right now. Okay, that is going to be T. Okay, which is going to be the sample mean from the first population, sample mean from the second population, and of course these are population mean. The difference of the population mean equal to 0. Okay, because that is what we hypothesize. You get what I mean? And of course, this guy here is a sample variance for the first, for the taken from the first population, and so these are sample variances. Okay. Now, let us look at an example right now. Okay, a headline in USA Today proclaim that men and women are equal talkers. Okay, that headline refers to a study of the numbers of words, the samples of men and women spoke in a day. Okay, so given below are the results from the study. Use a 0.05 significance level to test the claim that men and women speak the same mean number of words in a day. Okay, does there appear to be a difference? This is the data set we collected right now on men and women. We're talking about the words spoken by men and women. We actually want to see whether men and women on average, whether they are equal talkers. Okay, and you know what, the USA Today have conducted a research, okay, and they realize that they are equal talkers. Okay, based on the information we have right now, can we actually test if there's a significant difference between the average number of words spoken by men and women? Okay, now if you take a look at this, you are given a sample. Look at that. You're given the sample mean, and of course, this is a sample standard deviation, which means the population standard deviation is not available here. Okay, so in that situation, what you're actually going to do, you're going to start by first formulating your hypothesis, and I'll quickly take you there. The hypothesis you're actually going to formulate right here is going to be this. Okay, because if you go back here, it said, does there appear to be a difference? Does there appear to be a difference? Okay, does there appear to be a difference? It means not equal to. Okay, that is inequality. Okay, so it means the claim here is actually, does there appear to be a difference? Of course, the non-hypothesis is actually going to say equality. Because why is it going to say equality? Because of this guy here, because of the claim. Okay, said a headline in the USA Today proclaim that the men and women are equal talkers. Equal talkers is going to say, oh, the two means are equal. Okay, and the alternative is going to say the two means are not the same. And that is what we get that from here. Does there appear to be a difference? Okay, and of course, that is why we have this hypothesis formulation. Okay, and where the claim is on the non-hypothesis in this question, because the USA Today actually claim that men and women are equal talkers. Okay, now if that is the case right now, we're actually going to make use of the t-test. Of course, you specify the level of significance and take a look at that right now. You're actually going to plug in what is your sample mean. Okay, we've already plugged in that. What is the sample variance? Take a look at that. We plug in that, and we have our results right now. Okay, this is how to calculate that manually. Of course, my TA has already walked you through how to do this in R. Okay, so I'm just showing you right now how to do that manually. We got minus 0.676. Okay, so when you get minus 0.676, of course, the next thing you actually gonna, okay, somebody said, let me see, what is our degree of freedom in this test? Okay, that's a very good question. If you want to find the degree of freedom in this test, the degree of freedom is actually 185. How do I go 185? I'm actually going to show you right now. Okay, now take a look at the sample size, 186 and 210. Okay, you're actually going to make use of the smaller one. What is the smaller one? The smaller one is 186. Then you're going to subtract 1 from 186. when you subtract 1 from 186, what are you going to have? You're actually going to have the degree of freedom of 185. Does that make sense to the person that asked the question right now? Does it make sense to the person that asked the question now? Okay, so that is how we got that. Okay, so we're going to have a p-value for that. And don't forget, if you want to have a p-value for this, the nature of the test have to be put into consideration. Of course, the nature of the test here is alternative, okay? The nature of the test, this is a two-way test because the nature of the test, the name of the test actually depends on the nature of the alternative hypothesis, okay? So it's actually going to be a two-way test, okay? So, of course, you can use a p-value together. So, and of course, what I'm trying to obtain here, these are just the critical values, okay? But you know what? When you make use of R software, automatically R will give you the p-value associated with the test, okay? And you know what? Uh, you know, because the test statistic does not fall within the critical region, we fail to reject the null hypothesis. It means when you obtain the p-value for this test, okay, obtaining the p-value for this test, you are actually going to fail to reject the null hypothesis. And what is the null hypothesis? The null hypothesis is equality that men and women are equal talkers. So which actually give an indication that the USA Today, they were actually right, okay, in their claim that men and women are equal talkers. Okay, so um, is there anyone who want to ask question? Is there anyone want to ask question? How will you get a t value in R? Oh, if you want to get there's a code in R. I don't know whether my TA has walked you through that. I believe in the next lab you're actually going to do something uh, like that. Okay, so if you want to get the even the generality of the test, okay, there's something that we call t dot test. Okay, t dot test. Then you're actually going to indicate the population 1 and the population 2. Okay, so like I said, my TA is actually going to walk you through the code, okay, on how to figure that. It's very, very simple on how to do difference of means in R. Okay, what I just discussed with you now is when situation where this is just only part 1, okay, but you know what, I don't want to go beyond this, okay, because I actually want to finish my course, finish this course today, okay. So is there anyone who actually want to ask question or who need clarification? Is there anyone? Oh, can you guys confirm if you guys are hearing me clearly? Okay, let me say that this is where I'm actually going to stop today. And I want to officially announce to you that we just finished our lecture for the semester. Of course, from Monday, I'm actually going to be walking you through final exam review, okay, final practice questions, okay. So, and you know what, I'm actually going to be making, oh my god, no more parties, only that the party we're going to be having from Monday is just going to be reviewing final practice questions, okay. So, and I will encourage everyone to attend our review that actually going to start on Monday. And you know what, before Monday, I'm going to post some announcements over this weekend. I'm also going to post final practice question, and I'm also going to tell you the possible questions in the textbooks that you can actually you can walk around. Okay, so watch out for the information over the weekend. I first, I want to appreciate all of you, you know, for being good students in this semester, because I want to say, despite the fact that we don't meet physically, but you guys have really demonstrated the highest level of maturity, the highest level of tolerance, and the highest level of discipline. Okay, and I wish you guys, uh, a very successful career. Okay, I wish you very, best of luck in your career. And let me tell you this: be strong. I know we find ourselves in a world right now that is we're in the middle, because we're in the middle of pandemic and things are not that perfect. But you know what? Believe that you can actually get things done. Believe in yourself. Believe that even though we are in the middle of pandemic right now, we're in the middle of crisis right now, we're actually going to be fine. You're actually going to succeed. Okay. So, like I said, I'm actually going to be making some series of announcements starting, over the weekend. Check the canvas. The announcement is actually going to be on office hour, because by next week, I'm actually going to extend my office hours. So I'm going to communicate to everyone about the days over the weekend. Okay. So because I want to attend to every one of you, I want to hear from you. Okay. Don't hide your feelings. Okay. I'm going to have enough time. Since we have done now, I'm actually going to have enough time to actually listen to whatever, you know, that is likely to be your concern. Okay. So like I said, I really appreciate you guys for listening. I appreciate you guys with the way you have composed yourself, from the beginning of the semester to now. Okay. So all what I'm going to say, that you're actually going to go far in life. There's no limit to how you can rise in life. You can rise and rise and rise and rise and rise and rise. That's what I want. There shouldn't be any limit. Okay. The sky shouldn't be your limit. The sky is going to be your starting point. Okay. So make sure you stay safe and have a lovely weekend. Bye for now, guys. Okay. Thank you too. Thank you. Thank you too.